Hi, welcome to Exploring the World Ocean. I'm Sean Chamberlain. In today's lecture, I'd like to try to answer an age-old question. Where did Earth's water come from? How is it that Earth has a world ocean, whereas all the other planets in our solar system are virtually bone dry? Let's explore that question. To begin to consider the origins of Earth's water, we need to know something about how Earth and our solar system came about. How is it that the planets in the solar system formed, and what can we learn in their formation about the possible sources of Earth's water? Well, let's take a look at our solar system first. It's named a solar system because it consists of planets orbiting a sun. Our sun, whose name is Sol, is orbited by 8 planets. We used to have 9, but recently Pluto was demoted to the order of a dwarf planet. In order, the planets in our solar system are Mercury, the planet closest to the Sun, Venus, the greenhouse planet, Earth, where we live, Mars, the red planet, thought to harbor aliens, Jupiter, the biggest planet in our solar system, Saturn, the ringed planet, Uranus, that sounds like something else, and Neptune, my favorite planet, because it's named after a god of the ocean. These are our 8 planets. But as we'll see, our 8 planets aren't all alike. The Sun is the center of the universe and occupies about 99% of the entire mass of our universe, so it's prominent. The Sun provides us with electromagnetic radiation and solar energy that supplies heat to our planet, as well as supplying the ability to drive photosynthesis in plants, subjects we'll talk about a little bit later on in the semester. As I said before, our 8 planets aren't alike at all. In fact, we can group them. The 4 inner planets are called the rocky planets because they tend to be composed of dense rocks. The 4 outer planets are the gas planets because they're composed mostly of gases. If we take a closer look at the planets, and especially if we take a closer look at Earth, as we're going to do in our next lecture, we see that all 4 of the rocky planets have an inner core made out of iron and nickel. That inner core is surrounded by lighter things, lighter elements, silicates, things like granite and those kinds of things. This core, surrounded by other materials, is a hallmark of the rocky planets, and it's really a hallmark of Earth, or the structure of Earth as well. Now, what does this remind you of? Perhaps a Tootsie Pop or a Blow Pop, or maybe even an egg. If you were to cut apart an egg, you'd get a middle core surrounded by a shell of other material. That helps us think about the interior of our planets when we compare it to things that we know about. The gas planets, as their name implies, are composed of gases, mostly hydrogen and helium. In fact, Jupiter has a composition much like our Sun, but because its mass is not as great, it actually is a star that failed to ignite. So it's a failed sun, what we call a protostar. And although there is a core of some type in the gas planets, a type that we're not sure what those materials are, lighter materials perhaps, most of the planets are composed of a gaseous material. That's the rocky planets and the gas planets. Well, all the planets came about as a result of some disturbance in the cosmic fabric of outer space. In our case, it happened to be the formation of the Sun. When the Sun formed, it sent out giant shock waves, and those shock waves got the dust of the universe, the cosmic dust and gases, swirling. As they began to swirl, they began to stick together, not unlike what you find underneath your couch. Those dust bunnies are formed from smaller particles of dust that kind of glue together and make larger particles. Well, that's sort of what happened in the formation of our universe. These dust grains grew larger in size, eventually becoming more marble-like or baseball-like in size. And as this whirling dust and larger pieces of dust kept orbiting around and swirling around our Sun, they became miniature planets, little rocky fragments called planetesimals. And as the planetesimals collided and glued together and aggregated together, eventually they became a planet. This is the solar nebula model for the formation of our universe and for planets. And it tells us something about the conditions under which Earth formed and the conditions that must have been around when Earth obtained its water. An important part of this is the cooling of the solar system after its formation. It should be no surprise to you that the region closest to the Sun took the longest to cool before the planets formed. The outermost reaches of the solar system became cooler first, and so things that cool really easily, like gases like water and other types of gases, formed first, whereas these more dense elements like iron and nickel, the kinds of things we find in the core of the rocky planets, took longer to cool and condense. And so this difference between the gas planets and the rocky planets is really something that came about because of the way our solar system cooled. And that tells us also something about the conditions that existed prior to Earth obtaining all of its water. So we want to keep that in mind. As a little bit of an aside, we know that most planets have moons. Our moon, as it turns out, a recent hypothesis states that probably some Mars-sized planet slammed into Earth and in doing so ejected the moon out the other side.